Alright, let's look at 6.3 on geometric sequences and series. Our objective today will be to use geometric sequences and to find the sums of geometric series. And that falls under our standard of FBF2, dealing with geometric sequences through the recursive and the explicit formulas. So you'll see that the standard doesn't specifically address series. It does mainly work on sequences, but series are related. And so let's look at a definition here that we need to know. The nth term of a geometric sequence is labeled as a sub n, is the in which the first term is a sub 1, and the common ratios r is given by the following formula, where n is any natural number. And so the formula is this. It is a sub n is equal to a sub 1 times r to the n minus 1. Now, why n minus 1 power? Well, remember that we're already on the first term here, so we're only going to need to take n minus 1 steps to get to our requested term. And so let's see how that works out with example 1. We're given the sixth term of a geometric sequence where a sub 1 is equal to negative 3 and r is equal to negative 2. And so we get a sub 6 is equal to negative 3 times negative 2 to the 6 minus 1 power. And so a sub 6 is equal to negative 3 times negative 2 to the 5th. And please remember your order of operations. Do not multiply these together first. Make sure you take care of the power. And so a sub 6 is equal to negative 3 and negative 2 to the 5th. So it's negative 2 times negative 2 times negative 2 times negative 2. And we'll get rid of that error message. And we will see that this is negative 32. We're going to multiply that by negative 3. And so negative 3 times negative 32 is a positive 96. And so the sixth term of the sequence is 96. Now, if we want to find every term in between, we could use the r and times every single one by negative 2 and go from negative 3 to positive 6 to negative 18 and work our way up to that positive 96. But the formula allows us to get there a lot quicker, especially when our values get a lot larger. Now, just because we're solving for a sub n here doesn't mean I could have a different piece missing. And so look at example 2. A couple of examples here. I want to write an equation for the nth term of the geometric sequence. And we're given 4, 12, 36, and 108. And the sequence continues. And so when we want to write the equation of this, we want it still in this same form. A sub n is equal to a sub 1 times r to the n minus 1. And we're going to put a number in for the a sub 1. And we're going to put a number in for the r. But we're not going to put anything in for the n, because we want this equation to be open-ended so that I can find any term of this sequence. And so doing that in this case, we need to be able to tell what happens. Well, the first term is literally the first term. So 4 is the a sub 1. But then the question becomes, how do I go from one term to the next? We times it by 3. And remember, this multiplication factor, being positive or negative, being a fraction or decimal or integer value, does not make any difference. Whatever we're going to multiply by to get between every single term will be the r. And so I'm going to get a sub n is equal to 4 times 3 to the n minus 1. This is our final answer here. There's nothing else we need to do just to write the equation. Okay? Let's look at example 2b here. Write an equation for the nth term of a geometric sequence where a sub 5 is equal to 4 and the r is equal to 3. Now, to be able to write this equation, I have to know what a sub 1 is. I got to know the first term. And so this is where I was talking about before that we need to work a little bit backwards. And so I know a sub n is equal to a sub 1 times r to the n minus 1. And so I'm going to get the a sub n is 4, because it's a sub 5. The a sub 1 is our unknown. The rate we're told is 3. And what term of the sequence did we plug in for a sub n? It was the 5th term, so I'm going to get 5 minus 1 for this power. And so we're going to get 4 is equal to a sub 1 of 3. 5 minus 1 is 4. And so I'm going to get 4 is equal to a sub 1. 3 to the 4th is 81. I'm going to divide both sides by the 81 here. And so I get that a sub 1 is equal to 4/81. That doesn't reduce. And so this now will allow me to write the equation of this for any nth term. And so a sub n is equal to 4/81 times 3 to the n minus 1. This is our final answer for this problem. So again, understand what information you're given and work through the problem. Now, let's talk about geometric means. Geometric means are the terms between two non-consecutive terms of a geometric sequence. And so if I have a sequence like 1, 2, 4, 8, 16, and I just tell you that I've got 1 and 16 in the sequence, the geometric means would be all those terms between the 1 and the 16. It'd be the 2, the 4, and the 8. And so the common ratio can be used to find the geometric means. Now, pay attention to this question here. It says find the three geometric means between 3.12 and 49.92. Let's just write out what this means for a second. So this means that I have 3.12. There are 3 terms in the middle, and then I've got the 49.92. I can label this as my a sub 1, and I can label this as my a sub 5, because this would be a sub 2, a sub 3, and a sub 4. And so we can use our geometric sequence formula to figure out what the common ratio is, and then be able to figure out what these 3 geometric means are. And so I'm going to use a sub n is equal to a sub 1 times r to the n minus 1. And so I'm going to get the 49.92 is equal to 3.12 times the r. What is my n? It would be the upper term, so it's going to be the 5. So to the 5 minus 1 power. Dealing with the order of operations, I'm going to divide both sides by the 3.12. Dividing that, we get 16. So 16 is equal to r to the 4th, because 5 minus 1, right? And so now I'm going to take the 4th root of both sides. And don't forget that when I take an even root, what do we need in front of the radical? We need our plus or minus. And so our r is positive or negative 2. Now that seems a little strange, right? But it's not, because either answer makes sense here. And watch what happens. So to get this a sub 2, I can multiply by positive 2, right? And I would get 6.24. But I could also multiply by negative 2. And so it means that this would be positive or negative, right? I would then multiply that number again by positive 2. And that would give me 12.48. But if I deal with the negative every time, now we can't switch between positives and negatives every time and be like, I'm going to multiply by positive 2 this time and negative 2 next time. If I think about one sequence, I got to keep my r the same for the entire sequence. And so if I do the negative, the a sub 2 would be a negative, but then when I multiply it again, I'll come back to positive. So this a sub 3 term must be positive. I can multiply it by 2 again, and we're going to get 24.96, but that could be positive or negative. And so my 3 geometric means would be positive or negative 6.24, 12.48, and positive or negative 24.96. And so that's where we're at there. And so that leads us to geometric series. A geometric series is the indicated sum of the terms of geometric sequence. And so if I have 5 terms of a geometric sequence like we just did, I would take all 5 of those terms and be able to add them together. Now, there is a nice little shortcut to this, and it is these two formulas here, depending on what we're given. If we're given the first term and the number of terms in the sequence, and of course we would need to know the rate somewhere in there, then we can find it using the first formula. And so we would take the first term minus the first term times r to the n over 1 minus r, so long as that the r is not 1. As long as our rate is not 1, we're okay, because if the rate's 1, then nothing changes, right? Because anything times 1 is itself. And then the other formula is available to us if we're given the first term and a certain nth term of the sequence. And so let's see what happens in these problems. So in 4a, we're given that a sub 1 is equal to 2, the n is equal to 10, and the r is equal to 3. And so we're going to substitute into this first formula for this problem. And so s of 10, so the sum of the first 10 terms of this sequence is what follows. A sub 1 is 2 minus 2 times r, so the r is 3, to the nth power. Now you're going to see that this formula is a little different. We don't have the n minus 1 here. We keep the n without subtracting anything off, over 1 minus the r, which is 3. And so simplifying that, we're going to get 2 minus 2. 3 to the 10th is 59,049. This is all over negative 2. So I'm going to get 2, doubling that, and we're going to get minus 118,098. This is all divided by the negative 2. And then subtracting that, so we're going to get negative 118,096, and dividing that by negative 2. And so we're going to get 59,048. Now, it sounds like a crazy number, because I mean, we see that that number happened there. It is a little bit of a coincidence just with the values that we had, but the sum of the first 10 terms of this geometric sequence would be 59,048. Now we'll do example 2b, which is based on what we're given, the first term and an nth term. And you'll see that we don't have this nth term labeled as like the 7th term or the 20th term. We don't need that information for this problem to work out. We could be given and told that this is the 7th term, and so this is a sub 7, but that's not required. And so plugging into this formula, coming back up, a sub 1 minus a sub n times r. And so I'm going to get a sub 1, so this is s of n, is equal to a sub 1 minus a sub n times the r over 1 minus the r. And so s of n is equal to 12,000 minus 50 over a half. And so s of n is equal to 11,950. And dividing by a half is the same as multiplying by 2. And that's what we'll do in the next step. So doubling this up, we're going to get 23,900. So again, the sum of the first nth terms of this sequence would be 23,900. Again, I don't know how many terms that would be. We could figure it out based on the numbers, but that is what we are given. Okay? All right. So, example 5. Find the first terms of a series. Find a sub 1 in a geometric series for which the s is negative 315, the n is equal to 15, and the r is equal to 3. So we're working a little backwards here. And so based on what we're given, we'll deal with situation 1 and copy that formula down. And so s of n is equal to a sub 1 minus a sub 1 times r to the n over 1 minus r. All right, copy that formula down. Yep. And so plugging everything in that we know where it's at, so we're going to get the negative 315. is equal to our unknown a sub 1 minus a sub 1 times r to the n. So that's going to be 3 to the 15th all over our 1 minus r. And so simplifying this down, again, it's going to take a few steps to get this, but we'll see how it simplifies down here momentarily. 3 to the 15th is going to be a very large number. It is 14,348,907. This is all over the negative 2. And so our next step would be multiply both sides by the 2. And so we're going to get positive 630 is equal to a sub 1 minus a sub 1 times the 14,348,907. Now you're probably asking yourself, well, we've got 2 a sub 1s in this problem. How are we going to get to 1 a sub 1? Watch this trick. Remember factoring, right? I could factor out an a sub 1 and get 1 minus the 14,348,907. We do that. We're going to get 630 is equal to our a sub 1. And this is going to be 14,348,000 negative, of course, with in front, 906. And dividing both sides here, our a sub 1. And so we're going to get the 630 divided by negative 14,348,906. And this is going to be a very small decimal if we try to keep it as a decimal. As a fraction, we could reduce both these by 2. So we're going to get back to the 315, negative of course, and the 14,348,906 divided by 2 is 7,174,453. This is divisible by 3 and 9. 14, 15, that would give us 23, 28, 31, so that's not divisible by 3. So this would be the final simplified a sub 1. Again, it's not pretty, but it is what it is. And so that's the lesson here on geometric sequences and series. You will see a couple word problems in this, but it's just using our formulas to be able to know what values we are dealing with in a problem. And so if you need any help, you know how to get a hold of me. You got my email. And again, those Google Meets are open from 11 to 2. If you need any help, just send me that email first so I know which classroom to open. Y'all have a great day. Stay safe, stay home, and don't do anything dumb, y'all.